So today's video will be on multiple events using tables. Our learning goals for today, by the end of the lesson you'll be able to find the sample space for situations involving multiple events using a table, and you'll be able to analyse the probabilities of multiple events with and without replacement. Okay, so some key ideas here. So an array or table is often used to list a sample space for experiments with two steps. So for instance, two steps could be you toss a coin once and then you toss a coin again. So that would be the two steps involved. Or you have a bag of marbles, you pull one marble out and then you pull another marble out and you're writing down the colours. So when listing outcomes, it's important to be consistent with the order for each outcome. So for instance, if you flipped a coin and got heads and tails, that is a different outcome from flipping a coin and getting tails and then heads, because they're in a different order. You got them from different experiments. So you have to be very careful that you record the order precisely. So some experiments are conducted without replacements, which means some outcomes that may be possible with replacement are no longer possible. So for instance, down the bottom here, we've got a table, two different tables, showing drawing letters from the word cat. So there's 3 cards cut out with C-A-T and then again C-A-T. So in the first experiment there's replacement. So for instance, you draw out the letter C, write it down, put it back in the bag, and you can draw out another letter. So obviously you could draw out C again and you get C, or you could draw out C, put it back in the bag and draw out an A, or any combination of those. So you draw out the letter, write it down and put it back into the bag. On the right here though, we have without replacement. So that means you draw out a letter and once you've drawn it out, you don't replace it back in the bag. So for instance, if you draw out the A first, you put it aside and you can no longer draw out an A again. So all that would be left would be a C or a T. So without replacement, you're not adding it back into the bag, so it's impossible for you to get that letter again. So as you can see, it's impossible to get C and then C because you haven't replaced the C, so you can't get it for the second trial. Likewise, you can't get A and then A or T and then T because again, once you've drawn that letter once, you're not putting it back in there, so you can't draw it a second time. Okay, so I'll do a bit of an example here, probably become a bit more clear. So 2 coins are tossed, so we're going to draw a table to list the sample space. Okay, so obviously coin toss 1. Ooh, need to get practicing my writing there. Okay, so your 2 options for tossing a coin are getting heads or getting tails. So that's all you could get. And then this is a terrible table. Obviously, you would be using your ruler to do this. Okay, so then we've got a coin toss, which is our second one. So coin toss 2. And again, you could get heads or tails. So you can fill out all the options. So you could flip heads the first time and then flip heads again. You could flip heads with your first coin toss and then tails with your second. You could flip tails with your first coin toss and then heads, or you could flip tails on your first coin toss and then tails again. So that would be your 2-way table. Obviously yours would be more legible than mine and done with a ruler. So this is our answer to A. Also, you would work down the page. I don't have space, so I'm going to work across the page. For B, find the probability of obtaining heads and then tails. Now, remember what I said back a slide ago? The order is important. So tossing heads and then tails is not the same. So that is not equal to tossing tails and then heads. So it has to be that specific order. So if we look at our table here, we can see that there's only one option where we toss heads and then tails. So this one's here. So it's the probability of heads and then tails. It's 1/4. And it's just that option. So for C, we're finding the probability of obtaining 1 heads. So it doesn't matter what order, just as long as there is 1 heads. So I'll change my pen color. So this option here, flipping tails and then heads, that's one option of getting 1 heads, and flipping heads and then tails, that's your second option. So they're the only 2 options where you only get 1 head. Obviously if you flip tails and then tails, there's no heads there, or heads and then heads, there's 2. So that's not what it's asking us for, it's only asking for 1 head. So that's 2 out of the 4 options, which we can then simplify our fraction to 1/2. And that would be our answer there. Okay, so for our second worked example, we have 2 letters are chosen at random from the word tree without replacement. So that means we're not putting them back in once we've drawn them out. So obviously for our first round, we could draw out all the letters from tree. We have the possibility of drawing out a T, R, E, or another E. So draw that down. And then for our second round, we have the same possibilities depending on what we drew in the first. So our second round, we could also draw out a T, R, E, or an E. Now our question says there is no replacement. So that means if we drew out a T in our first round, we could not draw out a T in our second round because we're not putting it back in the bag, we're putting it to the side. It's the same for the R, the E, and the E. So you'll notice because tree has two E's, there is still the possibility of drawing out two E's. It's just not going to be the same E. So we could draw out a T in our first round and then an R, a T and then an E, or a T and then a different E. For R, a T, R and then E, R and then E, E, T, E-T, E, R, or E and E. So we are able to draw out two E's, but as you can see, it's because they're drawing out two different E's. So like the third E and the fourth E, not the third E twice because we're not replacing it. E, T, E, R, and E, E. Okay, so this would be our table. So for B, find the probability that the two letters chosen are both E. So the probability that they're both E, well, we just have to look at our table and count out how many options we have that they're both E. So this option is two E's and this option is two E's, and they are our only options. So our probability then is going to be 2 over our total number of outcomes. So remember, it's not the total number on the table because we've got some outcomes that aren't possible. So it's a total out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12. 2 out of 12. So we can then simplify that fraction to 1 out of 6. So 1 out of 6 is our probability of getting 2 E's. Now for C, I'm kind of running out of room, so I'll do it over here. Please work down the page. So find the probability that at least one of the letters is an E. Probability at least one E equals, okay, so we'll count up how many of these have at least one E. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is much higher probability. So this is 10 out of our 12 there. And we'll simplify our fraction to 5 out of 6. So they are our probabilities there for that worked example. And that's all we have for today's video. Make sure you copy down the notes, and any questions at all, please come and see me in class.